Good evening, I am Mr. Ish. You are all in for a treat here with this video, function questions. We'll be looking at two very important type of questions. This type you can actually see very well so on a higher level standardized exam, even a higher level subject mathematics exam. The very first question, if f of x is equal to that radical function, within the radical we have x squared plus 2x plus 1, for what values of x, if any, is f of x less than 0? Seems like a lot of fancy words. What does this f of x less than 0 mean? We're looking at y is less than 0. You know f of x is synonymous with y, so you're saying with regards to this specific graph over here or function, would there be any values for which if you were to plug in x-axis values, you'd have a function which would peep down here into the negative quadrants in terms of the y values? This looks like a difficult radical function, but it isn't. Think about it. X squared plus 2x plus 1 is no different than x plus 1 whole square. It is bounded by a radical, but look at this. It's x plus 1 whole square. And the radical is very well to the power of 1 over 2. Remember, to the power of 1 over 2, anything to the power of 1 over 2 is a radical, right? To this root, a square root. You can actually just cancel this out, and you're really looking at just an x plus 1. But the fact that we have a radical over here, we can't forget a very essential fact that you cannot put a radical and then expect to do a root of a negative number, especially when you're looking at an even root radical, a square root. You cannot do square root of a negative number, so you're really looking at a graph of x plus 1 in the absolute value, because the absolute value over there makes you think and focus on those situations where the values must be positive. So all of that entire function right here, very fancy looking function, really boils down to x plus 1 in an absolute value. If you were to graph it, you know you're looking at like an x plus h units shifted to the left, but these h units are really 1 unit. You have a vertex here at 1 comma 0, and this right here is a graph of absolute value of x plus 1. That right there is the graph of that function, and I've broken to you and shown it to you why that is the case. When you're looking at this graph, and now the question is, for what values of x, if any, is f of x less than 0, or where y is less than 0? Look at this. What's the range in terms of the y values? You're going from 0 up to infinity, including 0 up to infinity. That is, you're going no lower than 0 in terms of y value, and then you're only just looking upwards. So for what values of x, if any, is f of x less than 0? No values. There are absolutely no values of x such that if you were to put x in a value into this, you'd get a negative answer. You cannot, because the radical will always force you to look at everything in terms of positive, and I've already shown you everything here is really only this, and you'll always be looking at positive values in terms of y values, in terms of range. So what's your answer? There are no values for which f of x is less than 0, and that right there answer should be good. The second and the last question of this video has two parts. We look at one part at a time. A function has a range minus infinity to infinity and a domain of only minus pi over 2 to pi over 2. We have to suggest a possible graph. What can you do over here? This is the type of question where you provided a range and domain, and you have to think backwards and generate a type of a graph. We're looking at A only here. You always start these type of questions with what your domain is suggested, and you mark your domain. Our domain is from minus pi over 2 to pi over 2. You know, you're thinking of some sort of trigonometric function because we're looking at that. We can say minus pi over 2, right? And we can draw this. Why am I drawing dotted lines? Well, here's my minus pi over 2 and here's my pi over 2. The reason why I'm drawing a dotted line is because I have this circular parentheses, meaning the values are not included. The values of minus pi over 2 and positive pi over 2 are not included in the domain, but the curve kind of goes up to it but never really gets there. And we have a range minus infinity to infinity. I can come up with two situations. In terms of minus infinity, we have a line or a curve which will go from outside on the bottom to outside on the top. And I can think of something which goes like this, right here. It's going from minus pi over 2 to pi over 2, but never really touching it, and it's going from minus infinity to infinity. And that looks like a tan x. You don't even have to suggest what type of function it really is. You just have to do a curve, or you could have even shown something like this in this direction. And this could have been another possible answer, and that answer right there would be right. So you have two possibilities, something like this and something like this. It'll have a range minus infinity to infinity and a domain minus pi over 2 pi over 2. Let's look at here number B. We'll draw an x and y plane. We're looking here at a function which has a range 0 to infinity and a domain 0 to infinity. Suggest a possible graph. Again, I'm not seeing anything over here in terms of contact with 0. It's going up to but not including. and with range is going up to but not including 0, but it shoots up towards infinity. Let's look at the domain 0 to infinity. We could be looking at something which could be very well like this, a hyperbola. It's going from 0 in terms of lateral extent 0, never touching 0, and going in this direction towards infinity. In terms of range, it's going from 0, never touching 0 line, and going up here towards positive infinity, and that right would be a good hypothetical value of this type of a function. And now, just for interest's sake, I've changed the parameters here a bit for part B. I have a function here which goes from 0 including 0 up to infinity in terms of domain, and it goes from 0 including 0 up to infinity in terms of range. What could be a possible graph of this? How about this? Since 0 is included in terms of the domain, which is your x value, and range in terms of your y value, you know it's going to touch the origin 0, and then it's going to shoot in both dimensions like this. So it looks like a very well a radical graph to me. It's going to go in this direction towards infinity, and it's going to go upwards in terms of its extent towards positive infinity, and that right there would very well match the graph of B. And with that, I say everyone, thank you for watching my videos. Keep watching my videos, and I'll keep presenting interesting questions for all of you to solve. Have a good day. Bye.